Hello everyone. Welcome back to Python Challenge for All. Okay, so we were playing with the Gödel number. So let's continue our work. Last time we try to implement a Gödel function. Well, Gödel, yeah, we try to compute Gödel number out of a string or words um, yeah, by this algorithm, okay? And tried Japan, Tokyo, Monkey, and for example, out of say Monkey, we got a number consisting of how many? That's a long 64 words. Okay, so let's continue. So assignment was kind of homework. Create the inverse function that reconstructs the original string. Okay, so it's kind of a implementing a inverse function to compute from Gödel number to back to a string. Okay, were you able to do that? Okay, lesson 117, decode a Gödel number into a string. Okay, so let's continue. The Gödel number uniquely determines a string. Actually, yeah, one thing we need to check is that the backward computation can be uniquely determine a string because of the fundamental theorem of arithmetic, meaning that any positive integer can be uniquely factorized to product of primes. Okay, yeah, maybe it's easy to understand the essence, but a little difficult to prove. Okay, let's go on. So basic depend yeah, based on this fundamental theorem arithmetics, we can uniquely determine a string from a Gödel number. So how can we do that? So let's do that. So how to decode a Gödel number back into the original string. So starting from the Gödel number, of course, we divide. We do the same algorithm reverse order. Okay, so we divide by successive primes in order. So we would divide by 2, for example, and see how many times we can divide by 2. And then we divide by 3 and check how many times we can divide by, by 3. And each time that the times, the number of times we can divide determines the k. And then we can we can decide which character to come next by adding k to the ASCII code of A -1 and changing that to character corresponding to that ASCII code. And append that character to the end of a string and continuing it until the number becomes 1. Okay, so let's check the process one by one and that we can make it. So shall we start from here? So maybe last time we did this. So we make a list of prime numbers. And then let's do Japan first. Again, Japan was like we make 30 number this, which is stored here, ans, which is composed of 31 digits. Okay, so let's start from here. So let's define number, intermediate number as nn, and let's define a string, answer string, initially as empty. Okay, and then we check for each prime number in prime list to see how many times we can divide the nn by that p. We first try 2, right? PL starts with 2, 3, 5, 7, 11. So we start by one and see we initialize k as 0. Actually, we can see that the maximum number of k should be 25, 26. So we can go like this. And if nn divided by k, if it is divisible by p, okay, divisible by k, we um, divide it, divide equal p, and continue it until it is not divisible furthermore. So maybe one way to do is, maybe a little smaller, is if it is not divisible, break. Otherwise, we do n slash slash equal p and do the same k again. So we repeat this process until this is not 0. Okay? When it is not 0, meaning that it is not further divisible by p, it will break from the list. So each time the k is incremented by 1 and n is divided by p. Okay, so after that, we check the p as we saw on the slide. Now we have k, so we decide the next character c using this. So c equals characters of k plus ord a minus 1. This is what we did, what we used last time. Okay, this is the reverse of this expression, okay, statement. So now we can calculate the order of the character as k plus order of a minus 1 and change it to character c. And we add that character at the end of the string. Okay? Do you see that this adds a character, a single character at the end of a string, starting from empty string? So after each process, we check, say nn, say p, k, just in case we p to the power of k, and c, and a new ss. Okay, we do it to check the process one by one. When shall we break it? We break when nn becomes 1. Okay, I think this works. So after this, we break from the list. So we have now ans should be 1. The original ans. Okay, let's make it this way. The original ans change back to n as character. Okay. Okay, let's run it to see if what Japan if the this number inputting this number as ans is changed back to, let's see, let's run this. Okay, so it starts with this to 10 times 1024, so it should be j. Next character is starting from here, we repeatedly divide it by 3 only one time, so should be a, ja. Next, this number 5, this number can be calculated by 16 times by 5. I mean, this number is can be calculated 16 times by 5. So the next character is P. This number is divisible by 7 only one time. So JAPA. And lastly, this number can be divisible by 11, 14 times. So it's Japan, and it's now over. So the character back, the string corresponding to number, this number is Japan. Good. Now we have it. Okay? Hmm. Okay. Maybe we can write. Ah, yeah. Okay, fine. Let's try another one. Tokyo. So Tokyo, we have this one, 58 digit number. So let's give it to as NN and calculate the process. So again, uh, it's divisible by 220 times T. It's divisible by 315 times. So next character is O, divisible by 5, 11 times, divisible by 7, 25 times. Okay. And lastly, by O, 11 times. So Tokyo. Okay, great. Now we have that as well. Yeah. Also, we try monkey. Because we have upper here, we don't care about the case. So monkey, this 64 digits. Yeah, we can write that it is go back to, it is run it. We have original character or original string as monkey, all in uppercase, but it is correct. Okay, so this is how we can compute back to original string from any Gödel number. I hope you like that. And I hope you will try yourself with many examples or improve the code and to enjoy. Okay, that's all for today. Come back again. Bye bye.